I'm going to split this denominator up to be cos times cos. So I'll get sine over cos times 1 over cos. So like I say, just splitting this cos squared up into a cos times a cos, which is useful because I can now turn the sine over cos to be tan. And the 1 over cos, I can turn that to be sec. Why is that useful? Well, if you check your formula sheet, your formula sheet says that sec differentiates to be sec x tan x. Therefore, sec x tan x will integrate to be sec x. Next, we've got the integral of 4 cos squared 3x. Right, ignore the 4 and the 3 for now. We're integrating cos squared, and we know how to do that. That's with the cos double angle identity. So let's start by looking at the cos double angle. I know that cos 2a is equal to 2 cos squared a minus 1. Let's make the cos squared the subject. I'm going to add 1 to both sides. And then I'm going to divide both sides by 2. Right, so I would usually just integrate the half cos 2x plus a half here. However, I've got 4 cos squared. So I'm going to times both sides by 4 because of that. So times by 4 here, times by 4 over here. The 4 times a half is 2. 4 times a half is 2. The other adaptation I'm going to make is that instead of the a, I've got 3x. So if I swap this a to be 3x, then I also need to change this a to be 3x, which means I'm going to have 2 times 3x, which will be 6x. So this is what I'm going to integrate instead of the 4 cos squared 3x. The cos will integrate to be sine, but I need to divide by 6 because of the reverse chain rule. The 2 over 6 will simplify to be 1/3. The 2 will integrate easily to be 2x, and don't forget the plus c. I'm first going to expand the brackets. So we've got 1 squared plus 2 sine x plus sine squared x. The 1 will integrate easily, the 2 sine x will integrate easily, the sine squared won't. But that's okay because we know how to integrate sine squared. We're going to use the cos double angle formula. So I know that cos 2x is equal to 1 minus 2 sine squared x. Rearrange to make sine squared the subject. So I can now plug this in there instead of the sine squared. I've got a 1 plus 1/2, so I can collect up those like terms just to save me work on integration. The 1 plus 1/2 is 3/2. And now all of these terms will integrate relatively simply. The 2 sine x will integrate to be minus 2 cos x. The 3/2 will integrate to be 3/2x. The cos will integrate to be sine. But I need to remember to divide by 2 because of the reverse chain rule. So actually this half is going to turn into a quarter. And don't forget the plus c.